In problem 17, we are given a discrete probability distribution where our random variable x here represents the number of deaths from automobile accidents per year in a given city, and here's that distribution. So 5% chance of 0 deaths, 18% chance of 1 death, etc. So we want to find p of 3, so the probability of 3 deaths. So that is 22. So this is x, and then p of x. So 0.22, 22%. Probability of 3 or fewer. So 3 or fewer is going to be probability that x is equal to 0, 1, 2, or 3. So it's actually 0 or 1 or 2 or 3. So that's going to be a addition rule. So probability of 0 plus probability of 1 plus probability of 2 and plus probability of 3. So 0, 1, 2, and 3, that's 0.05 plus 0.18 plus 0.34 and plus 0.22. And we'll sum those up. So we've got 0.05 plus 0.18, oops, plus 0.34 and plus 0.22. So 0.79. So 79% chance of 3 or fewer. Probability of at least 2 deaths. So we would write that as probability that x is greater than or equal to. So greater than or equal to 2 would be 2, 3, 4, or 5. And again, those are or probabilities, 2 or 3 or 4 or 5. So it's an addition rule like we did up here. So probability of 2, 0.34, plus probability of 3, 0.22, plus probability of 4, 0.16, and plus probability of 5, which is 0.05. And add those up. 0.34 plus 0.22 plus 0.16 plus 0.05. 0.77. So 77% chance of at least 2 deaths. Find the probability of more than 1 death. So that's asking what's the probability that our random variable x is greater than 1. So more than is greater than. And so more than 1 would be 2, 3, 4, 5. Oh, well, that's the same thing as greater than or equal to. So it should be 0.77. Now let me show you another way to do this. So this is probability x is greater than or equal to, which is 0.77 from part C, but also we could do the opposite probability, so the complement rule. So this is 1 minus the probability that x is less than or equal to 1, which will be 1 minus, and then the probability x is less than or equal to 1, so that would be x equals 0 or 1 are the two ways to be less than or equal 1. So probability of 0 is 0.05 and probability of 1, 0.18. So we can use a complement rule to do that if we want. So 1 minus parentheses 0.05 plus 0.18. Close up our parentheses, and there's our 0.77 again. Next, they want us to compute the mean, mu sub x. So that's defined to be the sum of x times probability of x. So what you want to do here is you want to vertically list your x values and your p of x values. So that's just from above. And then in the next column, we're going to do x times the probability. So we're just going to multiply straight across. So 0 times 0.05 is 0. 1 times 0.18 is 0.18, and so on. 2 times 0.34 is 0.68. 3 times 0.22 is 0.66. 4 times 0.16 is 0.64. And 5 times 0.05 is 0.25. And then you sum these up, so you total, you'll get 2.41. Well, that's the sum of the x times p of x column. Well, that's what the symbol means. That Greek letter sigma means sum. So our mean here is the sum of x times probability of x, which is 2.41. Compute the standard deviation. So the variance is given as the sum of x squared times the probability minus the mean squared. Well, we've already got the mean, that's the 2.41 here. So we need to do a x squared column. So we've got x and we've got probability of x, and then this x squared column I just did 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And probability of x values just brought down from here. And now x squared times the probability of x, so I'm going to multiply these two columns. 0 times 0.05, 0. 1 times 0.18, 0.18. 4 times 0.34 is 1.36, 9 times 0.22, 1.98, 16 times 0.16 is 2.56, and 25 times 0.05 is 1.25. Then we sum all those values up, we get 7.33. That's this number, the sum of the x squared times probability column. So that is 7.33. And then minus our mean squared. So in part D, we got a mean, or sorry, part E, we got a mean of 2.41, and that gets squared. Let's compute this. 7.33 minus 2.41. That gets a square on it. 1.5219. And then sigma, the standard deviation, is going to be the square root of 1.5219. Let's go ahead and compute that. So second square root, 1.5219, 1.2337. And that's standard deviation of a discrete probability distribution. So this formula right here.